The law of conservation of mass. This law states that matter is neither created nor destroyed in a chemical reaction. Let's take a look at a real-life example, making an omelet. Here's the cast of my ingredients, also known as my reactants. Butter, 3 eggs with a tablespoon of milk, sauteed onion, bacon, bell pepper, tomato, and mozzarella cheese. As I make my omelet, I want you to check to make sure all of the aforementioned ingredients are included. Notice how I'm careful to make sure all of the ingredients are scooped out of the bowls and none are left behind. Were you paying attention? Did all of the ingredients make it into the omelet? Yes, every ingredient that was shown in the beginning ended up in the finished omelet. Furthermore, we can say that all of the reactants can also be found in the product. No ingredients disappeared and no ingredients magically appeared at the end. Now let's apply this concept to a chemical equation. Here we have nitrogen gas combining with hydrogen gas to form ammonia. Let's list the elements that can be found in the reactants and products. Notice we have nitrogen and hydrogen on both sides of the equation. According to the law of conservation of mass, there must be the same amount of nitrogen and hydrogen atoms on each side of the equation. Let's check to see. There's 2 nitrogen and 2 hydrogen on the reactant side, but on the product side there's 1 nitrogen and 3 hydrogen. This violates the law of conservation of mass. We must balance the equation. We must add a coefficient of 3 in front of the hydrogen gas on the reactant side and a coefficient of 2 in front of the ammonia on the product side. Now we have equal amounts of nitrogen and hydrogen on both sides of the equation. This satisfies the law of conservation of mass. For more on balancing chemical equations, check out my next video. Remember, when it comes to the law of conservation of mass, elements do not randomly appear or disappear. There is no magic in science. Thanks for watching and remember to subscribe below.